thanks a lot for joining us. Welcome to my
Good
channel.
morning, Vikas. Thank you for having me.
Can we start with a short introduction?
Absolutely. Hey everyone, my name is Faisal. I've been working in the IT industry for maybe roughly 17 years now because I graduated in 2005. But I started my career in 2004. I've worn many hats over the years. Been a business analyst, been a project manager, been a front end developer. Most recent work, I've been working at Accenture, specializing in artificial intelligence, specifically uh, chatbots and conversational interfaces and platforms. Currently working mostly on AWS.
Okay, that's great. A lot of freshers, like, they think of IT industry as just a set of Hello World programs, maybe a little more complicated versions of the Hello World. They really don't realize what senior people do.
Yes. The Hello World is great, and Hello World is what you need to do to get started. But when you get to the nitty gritties, right? And a lot of times, as you start to get senior, also, you start to get away from the technology aspect a little bit. For example, I'm leading a team of 6 at the moment. You start to get away from the tech, and you start to get a little bit more into management and the documentation, and making sure things are moving, and keeping an eye on the team and things like that. So I guess it's a double-edged sword. Hello World is kind of nice because you were at least closer to the code. But now, as you are progressing in your career, you're kind of stepping back from the technical stuff, and I miss that.
So, and what kind of work do you do? Like, how is your day?
What kind of work do I do? How's my?
Yeah,
Okay.
how is your day? Like, when you start your day, what kind of tasks are aligned for you?
Okay, so first, when I get up every morning, obviously after I do my morning daily routine, brush my teeth, etc., the very first thing that I have to do is I have to coordinate an onshore daily stand up with an India team, a team of 6 developers that I'm coordinating with over there. They're the ones who are basically doing most of the work on the ground. They go into the AWS account, create the Lambda functions, create the Lex conversations, things like that. My job is to get a status update from them. This is just a regular agile daily stand up, and it's roughly half hour. Then on most days, we start with either a story grooming session, or we do what's called a design session. Now, in the design sessions, I don't speak that much because I'm on the technical side of it. But if they're saying something, or if they have a question on the design session, that I have to answer and relate to technology, if this is possible or recommended, that's the kind of, and that's usually maybe 2 or 3 times a week as well. Moving on from that, throughout the day, I have multiple things that I have to do. For example, the what it was it last week, one of the team members was stuck in a UI problem, in the sense that they couldn't figure out exactly how to do just raw jQuery, because we hadn't decided on a front end library or a front end framework yet, how to do raw jQuery to create just a basic chat interface. So I did a knowledge transfer on that. That was one of the things that I did. Another thing that I had to do was help a team member on something related to AWS Comprehend. They had a question, and another team member had a question in relation to a story and other things that I had. And then the rest of the day usually goes into either getting into creating the architecture documents, or creating the design documents, or having multiple meetings, and basically as any additional questions come up, that's on me. So yeah, that's roughly my day. Stand-ups,
Okay.
design, a little bit of technical work, a little bit of mentoring, and a little bit of all that.
Okay, so a lot of it is just a problem comes up and then you handle it. It's not a defined day for you.
Yeah, but basically it's a lot more sequence than that, right? So we have a 2-week sprint here. So at the beginning of the sprint, we decide on the goals for that sprint and the stories, and we point the stories and what's supposed to go into the backlog, so forth and so on. Then throughout the week, my job is to make sure that those stories are getting executed, and the team is not getting stuck somewhere, and that we're able to deliver on we committed to deliver. So the rest of the day is usually either spent on, going into the rally board to make sure, hey, people are updating their stuff, if there's any problems, if they're doing code reviews and other things like that. But it sounds a bit chaotic, but all of it is geared towards making sure that we reach our sprint goal, right? Making sure that our objective for the sprint, which is to deliver the stories, is met.
Okay, that's interesting. So how do you find your journey? Like the early days, you were doing real code, then you moved into design, then I see you were a CTO for some time.
Mhm.
Mm, like, which phase did you like the most?
So the thing is, because I like the low-level coding and the coding aspect, the technical aspect of it so much, I actually have not stepped away from it in the sense that even this past week, I was, I did the UI piece of one of the thing that the team member was stuck in, and I actually created the code and I delivered the code and I helped them, etc. The reason I also don't want to get away from it is because I have a passion for it. I like it. So that's one thing. I haven't completely stepped away from it. But to contrast with that, yes, my basically when I started early in my career was mostly business analysis, a little bit of project management, a little bit of design work and things like that. So it wasn't much technical stuff anyway. But through the middle of my career is when I got into the technical stuff, and that's when I really started to enjoy it. Like, and I don't think I'm in the later stages of my career. I think I'm still in the early middle phases of my career. 15 years of experience is roughly middle, I think. When you get to 30 years, then I guess I'll see. But yeah, so what I do like about what I how I contrast it with is that code is very, what's the word I'm looking for? Code is code, and you get what you get, right? And it's very definitive, it's very defined, it's very structured. This is what it is, and this is where you're supposed to code, and you get a problem and you fix it, and okay, you have your answer, etc. When you get into the slightly on the management side, you have to start to learn to deal a little bit with uncertainty. There's uncertainty goes with what decision, and a lot of risks end up going on your shoulders, and a lot of management responsibility ends up going on your shoulders. So I missed that in the sense that it was simpler days. Um, Coding, at least being closer to the code, was simpler in the sense that, hey, this is the code, this is what I have to write, this is the problem I have to solve. It better meet the following testing criteria, it better integrate, so forth and so on. So I do miss it, but it's not like I don't enjoy what I currently do. Right? It's good too.
Okay, so it must have been a paradigm shift when you went moved into management side and uh, like reduce the code in your work. As you said, the type of work and the mindset that is required is a bit different. Like, was it a
It's
shock? How did you cope with that?
it's a lot different, especially for somebody who is technically inclined. It's very difficult to delegate work, and the difficulty arises from the fact that you're not the one writing the code, so you can't be sure what the other person understood, or you have to develop a certain level of trust in your team, a certain level of trust in the other person that they're going to do, and basically try to avoid micromanagement. What developers like to do is, hey, I wrote the code, I know it's passing the test, and it's passing this, and I'm good. But when you're delegating to other people, what the difficulty is, they're the person who is writing the code. Okay, it's no longer in your hands. So the ultimate product is no longer in your hand. You have this incredible desire, this incredible itch to actually go and start the coding, figure it out, figure it out, figure it out. That paradigm shift is essential, meaning the ability to delegate. Okay, this person, I know he's technical, I know he's knowledgeable, I know he is dependable and reliable, he's part of my team, I'm managing him, and if he gets stuck, I'm gonna assume that if he is stuck or if he has a problem, he's gonna come to me. If he doesn't understand it, come to me. That's the major paradigm shift, right? Going away from the low level coding to management, the ability to trust and the ability to delegate. For coders, that's kind of hard. They want they want in the nitty gritty, and that chaos of management escapes them.
So that's the major change that you need to learn how to delegate.
You need to learn, absolutely. If you don't, if you don't delegate and you end up doing everything yourself, or you end up becoming a micromanager, and nobody likes a micromanager. Okay, yeah, if you're telling your development team this is how you need to do it, it's etc. It's perfectly okay to mentor and coach. That's entirely expected. Okay, if somebody's getting stuck somewhere, or if you have a suggestion, or if they have a suggestion, it's collaborative, right? They're your team member, you are their team member. They're responsible to you, but you are also responsible to them. Okay, so it's collaborative. Don't, without the ability to delegate, and if you just go, hey, this is how you should be doing it, or this is exactly how you should be doing it, if you get too low, A, the team's productivity will suffer, and B, the team won't enjoy it, and C, you're one person, you can't do everything. It's not possible. That's why we have multiple people in the team, right? One person can't deliver everything.
When I look at freshers and college students, one problem I see among them is they're really confused with the amount of variety they have in the IT industry. Like when we passed out, it was just only question we had was C or Java. And that was the only choice we made. But today they have such a wide range to select.
Right.
How do you think they should go about it?
They should not worry about that. The reason they should not worry about that is the fundamentals of computer science over the years have not changed. What do I mean by that? When you're in college, by the way, my training is not in computer science. When I wanted to get into coding, I took all these courses myself. I took CS50, which is the Harvard version of CS100 myself, and a bunch of other courses, and data structures and algorithms, and I read CLRS, and I did all this myself. The reason I say don't worry too much about that is specifically for this reason, that the fundamentals of computer science related to technology don't change in which technology you go into. What do I mean by that? What is binary search? We'll take that as an example. How you implement binary search and recursively implement binary search does not change between Java, Python, C#, C++, whatever. The technology is irrelevant. What you need to understand is the control flow, object-oriented programming, how you write unit tests, and basically how to think algorithmically and how to solve problems using a computer. Okay, the syntax you can learn, and in fact, once you have the basic fundamental concepts down, let's assume for argument's sake you started out in Python, and you're like, oh my God, Python is popular these days, but so was XYZ language, and now it's, what was it? The PHP is no longer that much, and I wanted to learn PHP. Am I going to lose everything? No. If you decided on Python and Python tomorrow becomes irrelevant, nobody wants to deal with Python anymore. That doesn't mean your skills related to object-oriented programming, control flow, data structures and algorithms, doesn't mean that that's not translatable. All you have to do then is just look up the syntax. And that's easy. Just go to Google, read the documentation, ask a question on Stack Overflow, somebody who's senior, ask them. That part you can figure out. So the way that I tell them is, let's assume if the question is, because I have been asked that question, what language should I learn? I said, you're asking the wrong question. You should not be learning a language. You should not be learning a technology. Yes, you're going to need a language as a tool. You're going to need it in order to, learn, but you should be focusing on what are data structures and algorithms, how is information represented in a computer, and how do you solve problems algorithmically? How do you fundamentally represent real world objects into a program? Once you learn this fundamental, the technology sort of becomes irrelevant, because here's why. I've been into JavaScript, I've been into Python, a little bit of C#. Currently, it's all Node.js. All the stuff that we're going through is Node.js, and then there might be times where there is no code. A lot of these, modern cloud platforms, what do you need? All you really need is go into the console and perhaps a little bit of infrastructure as code and Terraform, and everything is created for you. Well, those fundamental concepts, they still help me today. So I tell people, don't worry too much about that. You're asking the wrong question. The question is, do you have your fundamentals strong? Beyond that, the technology, you can figure out the rest.
Okay, so focus on the core concepts, and the rest is just anything that comes forward incidentally, you can take it.
Yeah, you can, those are details. Details can be worked out.
Okay. So which decision in your life, if you can remember, really changed your life, changed your career, and you feel that that was the decision I made?
Around the year, I'm gonna say 2010, 2011, something like that. I was still not very on the technical side. I was still slight more on the BA side and business analysis and project management, a little bit like that. What I started to discover, and this can happen to anybody, was that my specialization had become extremely focused on one sector, which was government, and even then one very specific specialty within government. And what ended up happening was I was very much, basically I was very much, my career was kind of married to that particular organization and to that particular focus and that particular discipline. What I found myself facing a wall at that point was, if that project ends, or, and which it did eventually, all projects and all jobs end, that's not, it will happen. Okay. And I found myself there, that they were deciding on, hey, we're not going to go in this direction anymore, blah blah blah. And I was like, wait, this is my livelihood. I'm about to, like, I spent what, 8, 7 years in this discipline, and I'm just, what, am I going to go back to zero? What's going on? Panic mode. Panic mode. The It was around that time I made the decision. I was like, I'm never going to be beholden to any specific technology, any specific discipline, any specific industry. I'm going to make sure that I invest in myself. Roughly around that time is when I first took, when I first decided, you know what, I'm going to go into the technical aspect. I'm going to go into coding. That's when it was rough. Yeah, 2010, 2011. So I started to do really thoroughly, basically, and that discipline and that habit sticks with me even to this day. I'm still taking courses. I started to take these courses related to computer science, and basically, I asked one of my friends for help, and we developed a self-study curriculum. Okay, we went to MIT, the Harvard curriculum. There's a really good Pakistani university. It's called NUST, National University of Science and Technology. We went through their curriculum, and we put their curriculum side by side. It was like, okay, what do they expect their students to know, and why do they expect them to know it? One thing obviously came to mind: object-oriented programming. All across, everybody expected you to know. So I was like, okay, I need to learn object-oriented programming. Data structures and algorithms, absolutely, you need to know that. Okay, database fundamentals, okay, you need to know that. Mathematics, specifically, what's that called? Discrete math and mathematics for computer science. Okay, it's all across. What I started doing was I went back to school without going to school. I took the data. I basically took CLRS and started going through it. I took a multiple, actually, Coursera specializations on data structures and algorithms, and I started working. And I kept doing that and doing that and doing that and doing that until I was very solid foundationally on all the computer science stuff related to coding and stuff like that. Before that, I did know a little bit of coding. If you asked me to do a little bit of JavaScript, I could probably do it, but I was not fluent in it. That one decision, that one, like, when I faced that wall, and perhaps that's what sometimes you need trouble in your life in order to make a change. And when I saw that trouble, and when I discovered that, as well, like, I have to do this. And that decision, meaning going back to the fundamentals and keep working on, you know, um, database engineering, web programming. CS50 was another course that I took. Mathematics for computer science, basically object-oriented programming. I read an entire full stack merge and Mongo Angular Express notebook. What this did was, A, cleared my fundamentals, and B, now it allowed me to, if I want to take any path, right? It doesn't matter what path I want to take. If I want to learn a pipe technology, I want to learn Python, I want to learn Node.js, I want to learn C Sharp, I want to learn Java. My fundamentals are clear. All it is now is somebody says, Faisal, can you write the following piece of code in Java? Sure, I can do it. And it's, even though I've never programmed a day in Java, I have never done it. I can figure it out. So that's one decision that one decision that I made around 2010, 2011 to focus on the fundamentals, incredibly become laser focused on the fundamentals. Since then, that has paid me dividends every year of my career. Okay. I was able to easily switch to a different job, and basically that has helped me progress in my career. So focusing on the fundamentals, and basically what I would like to discourage people from is the freshers that are coming out of college are good. Meaning, if you are going to university, they're probably going to drill you on data structures and algorithms and computer fundamentals of computer science and how to think algorithmically and how to solve problems. But modern boot camps don't focus on that. Modern boot camps are just focused on stuffing information into your head. Let's assume it's I don't know, security boot camp or a full stack development boot camp or a cloud boot camp. They don't go into the fundamentals of computer science, and that's dangerous. That's dangerous. You'll get yourself in trouble. So the one decision that absolutely helped me in my career, focusing on the fundamentals, the rest will take care of itself.
Okay. Yeah, you gave an important point that when you learn something, focus on the fundamentals. And most tutorials that we see, YouTube videos and all, they don't focus on the fundamentals. They just focus on the hello world. So how did you identify sources of knowledge that gave you the fundamentals?
Great question. YouTube, and by the way, I'm just as guilty of creating those YouTube videos, right? I create those YouTube videos, and for the purposes of getting basic understanding, those videos are essential. Okay. You don't know what AWS Lux is. You don't know what AWS Cognito is. Great. Find a YouTube video on it. Hello world. Okay, now I figured it out. But that does not mean your fundamentals are correct. Okay. When it comes to the fundamentals of computer science, the way that I discovered it, obviously, when I wrote my own curriculum, by the way, I'm a certified technical trainer as well. So training is something that I do and I've done in the past a lot. But when I was writing my own curriculum, the first thing I did was I read through a bunch of like, what are the best universities when it comes to computer science? What comes to mind? MIT comes to mind, Harvard comes to mind, Stanford comes to mind, perhaps IIT comes to mind, etc. What are they teaching in their lower level curriculums? And if they're really teaching it, well, why is it so important, right? Why is it that everybody seems to be harping on data structures and algorithms, and everybody seems to be taking this CLRS book, which is the I think it's on the 3rd edition in a moment. Why are they doing that? The way I discovered what the fundamentals are and why I needed to focus on the fundamentals is I actually went through this curricula and I said, if all the best universities and all the best programmers in the world that are coming out of these places are focusing on this, and this is what they really do, right? There must be something to it. Okay, maybe I don't understand why learning from like data structures and algorithms is going to help me become a full stack coder. I don't get it. I don't understand it yet. In full stack development, what do I need to do? I need to learn how to configure a web server. I need to learn MongoDB. I need to learn Angular. I need to learn Express.js. I need to learn Python. I need to learn PHP. I need to learn Unix, whatever. Data structures and algorithms is teaching me none of that. None of that. Why is it then that all these great, like some of the best top-notch universities in the world are focusing on this? It's a good question, right? So I said, okay, you know what? Let's take a leap of faith. Let's see that if they are so good at what they do and turning out some of the best developers in the world, perhaps they know something that I don't. So let's go ahead and let's focus on first, let's take a 100 level course and let's go into data structures and algorithms. I went into that with that open mindset because at that time I did not make the connection. I did not know how learning data structures and algorithms, especially because data structures and algorithms is actually very difficult. Okay, it's not an easy topic and by any stretch of the imagination. Why is it that's really going to help me, right? Why is this fundamental knowledge really going to help me? At that time, I did not know. When I discovered, the way that I discovered is by number one, studying the curricula. And when I dove deep into it is when I realized they're not really teaching you any particular technology. They're teaching you how to think. They're teaching you how to solve problems. They're teaching you how to provide value, how to be good at what you do, not necessarily any specific technology. And now that I know that that's the fundamental skill that you should possess, regardless of where you are in your career, because that's the skill that will keep you employed and will keep you gainfully employed and happy in your career. Okay, how do you think about a problem? How do you solve that problem? How do you come up with a solution to a problem? That's the reason that all these fundamentals are so important. So yes, ultimately, like you said, those, you know, hello world, project zero type examples, they're good, and you do need to understand them. YouTube is full of them, but they will not teach you the fundamentals. So that's the reason. Now, if you, let's assume for argument's sake, you have taken your fundamentals, because you know how to solve a problem, any problem that comes your way, you will know how to solve it. At that point, you just have to figure out the details. That's all that is left, and that you can do.
So according to, like, you're saying that data structures and algorithms is the key that one should learn before anything else. And once you have mastered that, learning anything else is not as difficult. You can manage it. But
Precisely,
then how did
because
you learn data structures and algorithms? Where did you find
three,
them?
three sources. CLRS. I would not recommend anybody read that book unless they're very, very, unless they want to go to sleep. That book will put you to sleep very, very quickly. Okay, anybody having trouble sleeping, go read that book. You'll fall asleep. Now, why am I recommending a book that I found so boring? CLRS is more a reference book. Okay, if somebody has the discipline to go through the CLRS book in its entirety, good for you. You are amazing, but I couldn't do it. It was very near impossible. Okay. Okay, so I said, okay, I took the CLRS book, but whenever I couldn't understand a concept, that became my reference book. That's one. CLRS, it's MIT Press. CLRS, I think, stands for Klein. I forgot what it stands for, but if you just say MIT Press, CLRS, Data Structures and Algorithms, an Introduction to Data Structures and Algorithms, you'll find that book. It's freely available online. That's the first resource. It was more of a reference book than anything. Then I took two Coursera specializations. One is called the Data Structures and Algorithms Specialization by, I think, UC San Diego. And basically, they presented data structures and algorithms in Java. And then there's another one. I could probably look it up now, but I'm not going to remember the name. Data Structures and Algorithms. Alexander Kulikov was one of the instructors, and these guys, that data structures and algorithms specialization was incredible. Incredible. Every data structure or algorithm they went to, they explained, and big O notation, and what is space complexity, and what is time complexity, and why it matters. How do you test your code? How do you write unit tests? They went into all of that. But the beautiful thing about that specialization was it was code agnostic. You can do that. The first one that I mentioned, the UC San Diego one, was Java based. But the second one was code agnostic. You want to use it in Python? Go ahead. Okay, you can do this entire specialization in Python. And that one consisted of, I think, 4, maybe 5 courses. And the first one consisted of 4 courses. Okay. I don't think I took all the courses, because the last course in the first one was about like software engineering interviews, and I didn't find that course very useful. I dropped that one. But the other courses in that, so they were incredible. These were the 3 sources I used. Coursera, if you just go to Coursera right now, and I think most modern universities, they provide free access to Coursera anyway. I know IIT does, and I know NUS does, and a bunch of other universities do. As long as you have a university login, you can go to Coursera, and Coursera Plus is free for you. Go learn those data structures and algorithms. Those were my, like, that was my running the gauntlet. Okay, become super laser focused. And yes, it's going to be difficult. I will not lie. I mean, for computer science majors and things like that, they already know. But for those who want to break into computer science or break into programming, you're gonna need, that's not gonna be easy. Data structures and algorithms is a tough concept, but once you know how computers represent information and how to solve problems, it'll help you. It'll feed you the rest of your life.
That is one core thing to do for anyone interested in IT industry. Even if you come from CS background, one should make sure that they understand data structures and algorithms thoroughly. That's right.
Absolutely, absolutely.
So, how would you advise any fresh graduate coming up? Like one major advice is focus on data structure and algorithm. But other than that, what kind of skills do they require? Technical or non-technical skills? How should they train themselves?
Perfect. Great question. This is the same problem that I face, and it's a problem that everybody's going to face. Now, if you have the so I've been harping too much on data structures and algorithms. Let's assume that you've gone through that discipline. Now moving on, okay, now I know data structure and algorithms. Is a job just gonna fly out of the air and fall into my lap? Am I just gonna start my career by learning data structures and algorithms? And the answer is no. No, you're not. Data structures and algorithms are your fundamentals, but now you need to start getting focused. And the way I did it, and this is how I recommend anybody do it. Udemy is an incredible resource. Every basically there are so many boot camps and courses that are popping up all over the United States, and they're very, very expensive. Some of them cost $10,000, $15,000, $20,000, and the first 6 months they basically take you to the boot camp. The same or similar kind of information you can find in a $20 course in Udemy. Okay, so now that you've come out of, because you've done your 100 level courses, you've done your data structures and algorithms, perhaps you've done some mathematics or computer science, your fundamentals are solid now. Because you're going to be learning, you're going to know a little bit more about computer science. So what do I mean by that? These terms, full stack development, cloud engineering, artificial intelligence, these are not going to be completely unknown to you. You're going to have some familiarity with them. Okay, you're going to know what they mean. If not the details of it yet, you're going to know what they mean. So let's assume, for argument's sake, that after you've done your fundamentals and you've gone through your fundamentals, you realize, hey, I really like full stack. Okay, I really want to learn full stack. I said, great, go. Okay, that's your specialty. Go to Udemy and go find a boot camp that is specific. And that's what I did. Full stack boot camp, $20, doesn't cost me much. And by the way, Udemy is really nice. If you're a student and you tell them you're a student, and you can prove it with a .edu address, they'll add whatever course you request to your catalog for free. So Udemy can do that for you. I never had to do that, but I know a lot of students in the past, they were like, we're students that they just added to your catalog for free. So that's another resource. Now you take that boot camp and you're like, okay, full stack it is. Find the best boot camp, best rated. It has thousands of ratings. You do your due diligence. You research and Google the instructor, and you realize, okay, this is a good boot camp. Pay the $20, or if you're a student, get the free boot camp and start taking it. Now is the time to figure out if this is what you really want to do. Meaning, perhaps full stack was something you wanted and you wanted to learn about, but halfway or quarter way through the curriculum, or perhaps even early on in that bootcamp, you realize, okay, this full stack thing is not for me. I'm not enjoying it. Okay, and that's fine. What did you lose? You lost nothing. $20 at most. And even what you learned early on in that bootcamp, what happened? Well, nothing. Whatever you learned, it's going to be applicable somewhere down the line. You're perfectly within your it's perfectly within your purview to say, this specialization is not for me. I don't like full stack. I don't like cloud engineering. It just doesn't make sense. I don't like artificial intelligence. Go, that's perfectly fine. Move on. You can start a different boot camp. Now it's time to start discovering your specialty. Once you've learned the fundamentals, now it's time to start discovering your specialty. Take a boot camp on it. At the very least, make sure you go through 25 to 30% of that boot camp before you decide to give up on it. Don't just give up after the first, lecture. Okay, you're going to have to do a little bit of discipline and due diligence to make sure that, yeah, I know what this is about, and this is not something I want to do. Take 25 to 30, maybe 40% of the course, and then you can say, yeah, this is not for me. Okay, now you know full stack is not for you. Move on to next thing. You want to learn about artificial intelligence? Great. Find an artificial intelligence bootcamp on Udemy. Great. Now you go through that bootcamp. And perhaps you figure out that after all of this, that it's not full stack, it's not artificial intelligence, you really like cloud engineering. Great. You figured it out. Now go through that entire bootcamp, and now the rest of your training begins. Because even though you've taken one bootcamp, okay, and you've gone through it, there's still going to be gaps in your knowledge. No bootcamp can teach you everything, and bootcamp is specifically, as the name implies, it's supposed to drill you, but it can't take you into the depths of everything. So now, for example, let's say after taking a full stack bootcamp, and that's what your specialty is, you realize, I really wanna, I'm now a full stack engineer, and that's what I want to do. Go ahead, take tangential courses. Perhaps that bootcamp that you took did not go into as much detail on Git and source code management as you like, branching and code flow and other things like that. You need to know that if you want to be full stack engineer. Go to Udemy and find a course on it. Perhaps Angular is not as much in demand. The bootcamp focused on Angular, but it's no longer as much in demand. React is the hot new thing, and you really like React, and you want to learn React. Go ahead, take a course on React. You like, okay, Node.js, I kind of understand, but maybe I really want to learn Python. Go ahead, take a course on Python. Now it's time to start, okay, training and retraining and basically start getting laser focused on your specialty. You got your fundamentals, you learned your and discovered your specialty. Now it's time to specialize. Now it's time to start getting laser focused on your specialty. So meaning, number one, discover your specialization. Number two, start to specialize. Focus on that specialty. Number three and four, the third and fourth step is also very important. The third step is what I like to call the chicken and egg problem. And the chicken and egg problem goes as follows. The chicken and egg problem goes like, and this is the same problem I face and a lot of folks are going to face as well, is that in order to get a job, you need experience to get a job, to need experience to get a job. How do you solve that conundrum? That's your third step. That's your third major step. You got to solve that conundrum. How do you solve that conundrum? Now that you have started to specialize or you know your specialty and you've started taking training, a lot of these boot camps, they're going to, number one, take you through projects. Okay. They're going to take you through coursework and projects and other things like that. And they're going to give you the opportunity to contribute to open source. Do that. Anytime you do a project, add it to your GitHub profile. Okay. Publish it to your GitHub profile. Post it on LinkedIn, tweet about it, blog about it. Time to start tooting your own horn. Just because you're a software engineer, that doesn't mean the world knows you're a software engineer. Okay, nobody knows about you. It's time. One of the things at this third step is to start tooting your own horn a little bit. Start to market yourself. I like to call it networking and personal branding. Go to LinkedIn and start adding the people. Basically, LinkedIn is amazing. You want to be a full stack engineer? Go to LinkedIn, type full stack engineer, and every day to add 10 people to your network. Out of 10 of them, 2 or 3 are going to accept your friend request. And keep doing that. After you have hundreds and hundreds of connections, you're going to start posting about, hey, this is the project work I'm doing, this is the course work I'm doing, etc. Start tooting your own horn. Number 3, and the next one, which is, now that you're tooting your own horn, how do you get actual experience? Meaning, I just spoke about how tooting your own horn. The way you get actual experience is, number one, start contributing to open source. Anytime you contribute to open source, you're adding it to your LinkedIn profile, you're adding it to your resume, you're blogging about it, tweeting about it, telling LinkedIn about it. Second, start volunteering. There are countless volunteer coding opportunities. If you Google right now, right? I will go online and say, go volunteer coding opportunity. When COVID hit, there was a hashtag that was trending on Twitter. It was called Code for COVID. Code for COVID had a lot of volunteer opportunities. Go ahead, volunteer. And anytime you volunteer, you're adding that to your LinkedIn profile, you're tweeting about it, blogging about it, either creating a YouTube video about it, helping people on Stack Overflow. This is another way of adding experience. Project work, volunteer. Number 3, start trying to do freelance work. Now, freelance work has a little bit of a difficulty in the sense that in modern days, freelance has become very, very competitive. Okay, almost cutthroat competitive. But there is a little bit of a hack I want you to try. I haven't done this personally because I left that long ago. But there's plenty of people on freelancer.com and guru.com who are incredibly highly rated. But because they're so highly rated, their profiles are most visible in your specialty. For example, if they are a full stack engineer and they're rated 5 stars and they have thousands upon thousands of ratings, they probably have more work coming to them that they can deal with. If I were you, I would contact them and be like, here's my project work. I've been tweeting about it, blogging about it. Here's my LinkedIn profile. Here's what I've been posting on open source, etc. And then tell them, if there's a project that comes your way and it's a little too beginner for you, and why don't you source it to me? I'll do the first project for free. I'll do the first thing for free. And from then on, you can start to develop these professional relationships with them. And anytime you do either a freelance project, either when you catch it yourself or you do it with somebody else's help, put it on your LinkedIn profile, blog about it, tweet a bit about it, toot your own horn. Finally, now that you have done all of this, what's going to happen? Basically, at this point, if you follow this path, you're a software engineer already. Okay, you've already done your specialization. You've already done the due diligence. The only thing that's left to do is basically go ask somebody for a job. And at that point, your LinkedIn resume is going to be full of references, whether it's open source contributions, project work, freelance work, or anything like that. You will already be what you want to be. The only thing left to do is just ask for a job. And somebody, trust me, there is so much demand. Somebody will be willing to pay you for it.
Yeah, these are some very concrete steps that you have told. It's very interesting. Very few people have thought about this.
The reason is because I recently posted a video about this on my YouTube channel, and these are the steps I took, right? The reason it's so concrete in my head is because that's how I got here. Okay, my journey is identical to what I have described here. My journey was slightly different, meaning I didn't do much freelance work, and things like that. But if you were to go through my profile and trace through my past, this is what I did, right? I became a software engineer not when I got my first coding job, because it was very fluid. Some jobs involved a bunch of things. It was business analysis, a little bit of coding. So when was I software engineer? Was it when I had my first job? No, I've never been unemployed for more than 3 or 4 months at a time. And of the 15 years that I had, I think total 17 years, I think the total time I was unemployed when I was in between jobs, or maybe 3 or 4 months, that's it. So then you must be thinking, well, when was it when I was a software engineer? And the truth is, you become a software engineer way before almost you get your first job in software engineering, right? The only thing left to do is, because if you've done it, right? If you've done the due diligence, you've taken your fundamentals, you've done your data structures and algorithms, you've run through your boot camp, and you've figured out your specialty, and you've become laser focused, and you specialized, and you trained in your specialty, and then you did open source contributions and freelance work and like project work, etc. And you've networked and personal branded and told people about what you do. Well, guess what? You took all these steps. You're a software engineer already. This is what software engineers do. What software engineers do is not something. It's not some major secret. There's no big secret. This is what it is. It just takes a lot of time and discipline. That's all it is.
So that's very nice. I'm sure a lot of people watching this video will gain some insight on this, because I've seen a lot of people are stuck in this chicken and egg problem. They don't know how to break through. You've given very nice steps that one can use to break through it. It's really great.
Awesome. I'm glad I could help.
Thank you. Thanks a lot for your insights.
Okay, no problem, Vikas.